All right, Algebra 2. Today we're doing simplifying square roots, in this case radicals. This, when you see that, is a radical. The interior number, for instance in the first one, 0, would be called a radicand. So let's get some words going. This is a radical. That whole house little thing over the x is a radical. And the stuff inside the radical, radicand. I don't know how savvy we're going to be using these terms, but you'll hear me use this, radical and radicand. Now what we're going to talk about is perfect squares. You need to know this. The square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Square root of 16, 4. Square root of 25, 5. You can see the pattern here, right? You need to know these. This is an easy lesson if you know your times tables. If you don't know your times tables, it's going to be kind of annoying. So keep that in mind. Technically, when you take the square root of 1, it's actually plus minus 1, and square root of 4 is plus minus 2, but we're going to get into that later. For now, we're just taking the positive side of the numbers. And that's that. Those are perfect squares. This means, let's take 16, for instance. The square root of 16, it means that if you multiply 4 times 4, you're going to get 16. That's all it means. It's not that big of a deal, but it can get confusing. So I'm going to go ahead and push pause and let y'all read this stuff. This may not make sense to you, but I don't want to read this out loud. So go ahead and read it. Okay, hopefully you read it. I'm going to go ahead and just assume you read this, and then I'm going to show you how to do A. I'm going to show you how to do all of these, actually. So here's what happens. When you come up to a radical like this, and you can tell the 12 is not a perfect square, you have to then jump into action and figure out some stuff. The goal is to simplify the square roots. So I'm going to show you what I'm going to do. I rewrote this entire thing, that is a times sign, that is the square root of 4 times 3. Why did I do that? Because 4 times 3 is 12. And what do I know about 4? That it is a perfect square. So what you're trying to do is split apart these numbers, 1 to a perfect square and 1 to a non-perfect square. And in this case, we were able to do that. So this is step 1. Step 2, right here, you can pull it apart even further. Now you have square root of 4 times the square root of 3. And now they're in separate little houses, i.e. radicals. And that's great. Step 3, let's go to it. Take the square root of 4, which is 2, times the square root of 3. There's nothing in there you can do. So 2 times the square root of 3, you put your answer together looking like this, 2 square root of 3. You're done. Let's move to 18. I know from my times tables that I can split this up into 9 times 2. I'm going to split this up into square root of 9 times square root of 2. Square root of 9 is 3. So I ended up with, here's my 1, here's my 2, here's my third step. Square root of 9 is 3 times square root of 2. My fourth step, I just shove them together. There we go. That's how this works. I'm going to go ahead and finish these other ones quickly so you have guided notes if you don't pay attention in class. 48, square root of 48, let's do it. I know from being a math teacher that I can break this up into 16 times 3. So check out how I did that. You can check yourself. 16 times 3 is 48. The square root of 16, why did you choose 16? Because it's a perfect square. Because I know my math, that's why I chose it. Your job is to be able to find perfect squares inside each of these problems. Boom. I'm going to show you 75 now. I can break this up as the square root of 25 times the square root of 3. So let's go ahead and show that. Square root of 25 is 5. And you end up with this. Again, the hard part for people who don't know their times tables is going to be knowing which numbers to use. At this point in your life, if you haven't learned your times tables and you're still resisting it, like, get over it. Figure it out. You'll spend so much time on your TikToks and all this stupid stuff. You could literally spend 15 minutes a day going over your multiplication tables online, and within 6 weeks, you could have them down. That is just so irritating to me that y'all don't. And then it makes teaching horrible because y'all are supposed to know some stuff and y'all don't, and it's like, okay. And it frustrates me because I'm like, why wouldn't you want to know your times tables? As an adult, like, come on. Anyways, that's my rant. Done. E can be split into 25 times 2. And then the square root of 25 times square root of 2. Square root of 25 is 5. I'm going to break that up. 5 square root of 2. Cool. Let's go to 56. This one I actually had to use the calculator for because it splits into, what was it? Hold on, let me look again. 1 second. Splits into 4 and 14. Whenever my brain does these problems, I'm always expecting a big square root to be taken out. So when it ends up being a small one, my brain does weird stuff. So the only root we can take out on this one is the square root of 4. Square root of 4 is 2 times square root of 14. And then we end up with 2 square root of 14. Going to the next one. And the last ones. Okay. Oh my God, mister, there's already a number in front. What do I do? Okay, well, this panic, quit, don't do your work, blame the teacher, do everything you'll normally do. And then when you're done with that, let's go ahead and take a look at this. I'm going to rewrite this problem. 3 times the square root of 60. And then I am going to, come on, can't even write 60. Make fun of y'all and then I can't even write. 3 times the square root of 60. I'm going to break apart 60. 3 times the square root of, what can I break it into? I believe it's 4 times 15. I'm always looking for those big square roots, but sometimes it's just the small ones. Watch how I'm breaking this up. See how you methodically do this? Square root of 15, nothing gets taken out of that. Square root of 4 breaks down into the square root of, breaks down to 2. And now I have 3 times 2 times square root of 15. 3 times 2 is 6 times the square root of 15. And then 6 square root of 15. If you follow this method, you can't get these wrong. Now I have negative 5 times square root of 32. I'm going to break this up. Negative 5 times the square root of 16 times 2. 16 times 2. How do I know that? Because math teacher. Now I'm going to rewrite this. Negative 5. Let's see. Negative 5 if I can. Negative 5 times square root of 16 times square root of 2. Negative 5 times 4, because the square root of 16 is 4, times square root of 2. Negative 5 times 4 is negative 20 times square root of 2. Negative 20 square root of 2. Y'all, you do not have to show this much work for these. But this is just for those who need the methodical thing. If you break this apart over and over and over again, you can see how this works. I will be teaching this in class as well, but this is for anybody who's doing their work legitimately at home or just need extra help. Good luck.